Okay, so here we are. Today we will be solving the mock paper of practical, the identification test practicals of AS level practical chemistry of Science Academy, and this test is about identification and skills of denoting or identifying various kinds of ions and compounds. And in the meantime, we are here the sample paper of our candidate who has responded to the question. So let's move on from the first practical. Okay, so the first question asked about you have to identify various anions and cations by testing with reagents as stated. So here the reagents are stated and you have to do the practicals. Okay, so to a small spatula of solid labeled Fa1A, add 2 cm cube depth of distilled water and add sodium hydroxide. Okay, so since it said that just add the sodium hydroxide, that is no specific amount has been mentioned. So what you have to do is that you have to put some few drops until a change is observed, and then when a change is observed, then you have to carry on adding the drops until you add the excess amount of sodium hydroxide. Okay, so this is Fa1A. So we are adding a very small amount, a very small spatula. And then we have added a small amount of distilled water to dissolve the solution, and here is the sodium hydroxide. Okay. So first let's add small amounts. Look, it's a green, it's a dirty green precipitate that we have obtained. Now we are adding excess. So let's add some more. Okay, so as we have added more and more of the excess, the precipitate still remains, isn't it? So we have to write that dirty green precipitate is formed, but the precipitate is insoluble in excess. Now the second question, the second part asked about heating the solution and test any gas involved. Now while you are heating the solution, just remember that a gas may be evolved, and while you are heating a solution, there are only two possibilities of gas evolution. It may be ammonia, or three possibilities. It may be ammonia, it may be oxygen, or it may be NO2, or whatever it is. NO2 is an optional, but it may be NH3 for quite sure. And you don't need to taste the gas, you can easily identify it by its pungent smell. Like I'm heating the solution, and here I have the damp red litmus paper. So when I'm testing the gas, I will be holding the litmus paper like this. I have just kept it over here and carry on heating. Look, I'm heating by hand, but during examination you must use a test tube holder for heating the gas. For heating the solution. First of all, why I am thinking it's ammonia? Because you are adding sodium hydroxide and you are heating the gas. So when you are adding sodium hydroxide, not a gas, it's a liquid. So when you are adding sodium hydroxide and heating a liquid, there is a 99% possibility of evolution of ammonia gas. Alright, so since I have added sodium hydroxide and I am heating the solution, so there is a possibility of evolution of ammonia gas. And if I am just adding sodium hydroxide, not anything else more, just sodium hydroxide, and heating the gas and ammonia gas is evolved, then ammonium ion must be present in the solution. Ammonium ions must be present, isn't it? Look, the litmus paper has started to turn blue over here, if you can see. Let me just focus it. The litmus paper has turned blue, isn't it, on the top surface here? So the gas evolved is ammonia gas. So this solution, the FA1A must contain iron 3+ ions, because it has given dirty precipitate which is insoluble, and also the ammonium ions. Alright? Okay. Okay. So I have cleaned the test tube 10 times. So in our first experiment, it will be dirty green precipitate which is insoluble in excess, which the candidate has not written here, so his marks will be penalized. And later on he has heated the solution and ammonia gas were evolved. Okay, the smell was not bad, but it's too bad. Okay, now to 1 centimeter cube depth of solution labeled Fa1A, add few drops of barium chloride or barium nitrate. So while you are adding barium chloride or barium nitrate, just be sure that it may be sulfate or sulfite. Look, I am taking very small amount. It's a very small amount. I think you can rarely see it, isn't it? Okay, so here I have added distilled water, very small amount. Now I will be adding what I have. I have barium nitrate. Look. So it's giving a white precipitate, isn't it? So it's giving a white precipitate after adding barium nitrate, which means that this solution may contain sulfate or sulfide, but this solution may contain sulfate or sulfide, but we are not sure about it, because you have to then add either nitric acid or hydrochloric acid to test the solubility of this precipitate. If the precipitate is not soluble, then for sure it's sulfate, but if it's soluble, then it's sulfide. But here no instructions are given for further test, so we should not carry out any further test. Now let me clean the test tube. Okay, now 1 centimeter cube depth of solution labeled Fa1B, add sodium hydroxide, and also look at the test of Fa1C, because it's so much disgusting to hold this paper and show it again and again. Just look. Okay, so I am taking Fa1B, isn't it? Where is Fa1B? Where? Oh, here it is. So it's Fa1B. So I am taking 1 centimeter cube depth of Fa1B, and then I am adding sodium hydroxide until no further change. That means again no specific amount is mentioned. So first, just look. So first I will be adding a few drops. Look, a precipitate started to evolve, which is also green in color, isn't it? It's green. It's green, dark green. So now I will be adding excess. Still, oh, the precipitate is going away. Oh, okay. So the precipitate formed is a green precipitate which dissolves in excess to give a green solution. Okay, so if you look at the data analysis table, look at here, a green precipitate formed which is soluble in excess, giving a green solution or dark green solution, whatever it is. So it will be chromium. And look, just few moments ago I have said, if you just add sodium hydroxide, there will be no precipitate of ammonium, but when you are heating, it will produce ammonia gas. But we have obtained a green precipitate in Fa1A, isn't it? So green precipitate which was insoluble in excess, it must be Fa2. So in Fa1A we have Fe2 plus and NH4 plus, and also we have got, it may be sulfate or sulfide, whatever you write, it will be correct, no problem. And in Fa1B we have got chromium. Okay, now Fa1C says that you have to add sodium hydroxide dropwise until there is no further change. Okay, so I have cleaned the test tube. I am doing a test in the same test tube over again and again by cleaning it, because using a lot of test tubes will create a lot of hassle. So I am now going to do test on Fa1C. So this is Fa1C, this is Fa1C. Okay, all right. Then I will be adding sodium hydroxide again. Fa1C, just look carefully. So it seems to be a white precipitate, isn't it? Oh, it's turning brown rapidly. Yes, it is. It is turning brown. Oh yes, it's turning brown. So first we have obtained a white precipitate, but which has immediately turned brown because it is exposed to air, isn't it? So what can it be? Okay, so I've cleaned the test tube immediately because I don't like actually precipitate staying in test tubes if the question don't ask. Okay, so look, it's a type of white or off-white, whatever you say. It's an off-white